Hi everybody, and welcome to Chem Talk, where today we will be going over formal charge and running over some examples of it in chemistry. So let's talk about it. Formal charge is the charge given to an atom covalently bonded to other atoms based on the number of lone pairs and covalent bonds the atom has. Formal charge helps determine what the best possible Lewis structure is for a molecule. Among all the various resonance structures, using formal charge to find the best one would mean all the charges on each atom are as close to zero as possible. Some other good terms to know are lone electrons, which are electrons on an atom that are unbonded, and a covalent bond is when a pair of electrons are shared between two atoms. A lot of times, these electrons aren't shared equally, but for determining formal charge, the assumption is made that all the electrons shared are evenly shared between both atoms. There's a kind of formula one can use for determining the formal charge on any atom in a molecule. Its formal charge equals the number of valence electrons of the atom in ground state minus the number of lone electrons and the number of bonds. The valence electrons are the number of electrons in the valence shell of the atom when it is in its neutral state. Let's take an example of SO2 with one specific Lewis structure. We can keep in mind there are multiple resonance structures for this compound. So in this Lewis structure, we have the oxygens double bonded to the sulfur atom, as well as a lone pair atop the sulfur atom. Let's take the formal charges of the oxygens first, since they both have a double bond and two lone pairs. It's safe to say that their formal charges will be the same. So the number of valence electrons the oxygen atom has in its ground state is 6. So that's our first number. The number of lone electrons on it is 4, and the number of bonds is 2. So using the formula we have, 6 minus 2 plus 4, which equals 6 minus 6, which equals 0. So 0 is great, because as I mentioned earlier, we want to get the formal charge on atoms as close to 0 as possible. Now, for the sulfur atom, in its ground state, it has 6 electrons. It has 2 lone electrons and 4 bonds. So now using the formula, we do 6 minus 2 plus 4, which is 6 minus 6, which also equals 0. So this is definitely a really good Lewis structure for SO2, as all the atoms have a formal charge of 0. Something you can do with formal charge is use it to rank all the possible Lewis structures for a molecule. One good rule to go by is the most negative formal charge goes on the most electronegative atom. The way to determine how good or bad a Lewis structure is using formal charge is to determine the formal charge on all the atoms in each Lewis structure, and the one that is best will have the lowest charge on all atoms. As a tip, usually any structure where an atom has a charge of 2 or more is considered poor. When choosing among several Lewis structures with a similar distribution of charges, the structure in which the more electronegative atom has the more negative formal charge is preferred. Let's take the example of N2O and use formal charge to pick the best Lewis structure for the molecule. Let's use these 3 structures here. First, it's good to acknowledge that oxygen is more electronegative than nitrogen, so if there needs to be a negative formal charge, we want it on the oxygen. In the first structure, we have 5 electrons in the valence shell ground state of nitrogen. Then we subtract 4 for the 4 lone electrons and 2 more for the 2 bonds. That gives us a formal charge of -1. The other nitrogen, we just subtract 4 from 5 because of the 4 bonds to give us +1. The oxygen has 6 electrons in its ground state valence shell, so we subtract 4 from that for the 4 lone electrons and 2 more for the 2 bonds to give us a formal charge of 0. So right away we see the less electronegative atom has the negative formal charge. So I have a feeling if we keep going we can find a better structure. With the next structure, we have this nitrogen here. So subtract 2 from 5 for the 2 lone electrons and 3 more for the 3 bonds. That gives us a formal charge of 0 for this nitrogen, which is really good. The next nitrogen, we subtract 4 from 5 due to the 4 bonds, and that gives us a positive formal charge of +1. Finally, from the oxygen, we subtract 6 from 6 for the 6 lone electrons and 1 more for that 1 bond. That gives the oxygen a formal charge of -1. So this structure actually looks pretty good because the negative charge is on the more electronegative atom, and between the two nitrogens, only one of them has a non-zero charge. But let's take a look at this last one just in case. So the first nitrogen has 6 lone electrons and 1 bond, so we subtract 7 from 5, giving us -2. The second nitrogen has 4 bonds, so we do 5 minus 4 to get +1. And finally, the oxygen has 2 lone electrons and 3 bonds, so we do 6 minus 5 to get +1. So this structure is actually quite bad. For one, we have a nitrogen with a charge on it with a magnitude of 2, which is already pushing it. But on top of that, the most negative charge is on the nitrogen, and not the more electronegative oxygen. Instead, the oxygen has a positive charge of +1. So this is probably the worst option here, and we can confidently say that the middle structure is the best structure when considering formal charge. There is a little handy trick to help figure out if an atom is going to have a non-zero formal charge, and that would be looking at how many electrons it is missing to complete a full octet. Let's use oxygen for an example. It has 6 valence electrons and needs 2 to complete its octet. It just so happens that when oxygen has 2 covalent bonds with another atom, and the appropriate amount of lone pairs to go with it, its formal charge is 0. Again, with nitrogen, it has 5 valence electrons and needs 3 electrons to complete its octet. It just so happens that when nitrogen has 3 covalent bonds with another atom and the appropriate amount of lone pairs to complete its octet, its formal charge is 0. So, the amount of electrons a nonmetal is missing can help you figure out how many covalent bonds it should have to have a formal charge of 0. In summation, we learned that formal charge is the charge given to an atom covalently bonded to other atoms based on the number of lone pairs and covalent bonds the atom has, and can help determine the best Lewis structure for a molecule. The formula to determine formal charge is formal charge equals the number of valence electrons minus the number of lone electrons and bonds that the atom has. The more electronegative atom should hold the most negative formal charge. And a fast way to see if a nonmetal is going to have a formal charge of 0 or not is to see how many valence electrons it is missing to complete its octet and compare that to the number of covalent bonds it has. If the numbers match, it should have a formal charge of 0. So that is all for today on formal charge. Thank you for tuning into ChemTalk. Make sure to visit our website www.chemistrytalk.org for hundreds of general, organic, and biochemistry articles.